Hi everyone, Miss Andronicus here, and today we are looking at back-to-back stem and leaf diagrams. To consider back-to-back stem and leaf diagrams, we must first consider regular stem and leaf diagrams, and they are used to organize data in order of size. Have a look at the example below. You can see there are numbers on the left side of a line and on the right side of a line. All the numbers on the left side of the line are what we call a stem, and all the numbers on the right side of the line are the leaves. Okay, so the stem and the leaf. And the stem needs to be matched up with the leaves. So what actually happens is this indicates the first number that you then have to put with each one of these leaves. So essentially on that first line, you've got the number 18, 19, and 20. Now, that stem can represent any number of values. So instead of 18, as I suggested, it could actually also mean 1.8. It could also be 1800, 180, 18 million. It could be any value with a 1 and an 8. And what indicates which value it is the second part of a stem and leaf. The most critical part, so that you can understand the stem and leaf diagram, is a key. And the key is written like this. There's a couple of different sort of little variations. You could say equals, means, represents. There's a few different words you could put in there, but generally it's like taking a portion of the stem and leaf. So 2, and that indicates that line down the middle, and then 3. So it's like saying the 2 with the line down the middle and 3. It doesn't matter which numbers you choose. That will equal 23 years. So if, for example, we wanted 2 line down the middle, 3 to equal 2.3, that's what it would indicate. Okay, so that's how we know it can't be the 1.8 and it can't be that. It must be 18 because 2 and 3 is 23. So it must be 10s for the stem and 1s for the leaves. The other thing stem and leaf diagrams do is if I kind of draw around each one of these rows, it gives us a little indication of a pattern. So it's like looking at the distribution. So if we're considering people in an office, the ages of people in an office, you can see most of them are in their 20s or 30s. So they are quite a young office, we would say, a young office. So that also gives you the opportunity to draw conclusions from this stem and leaf diagram, and it creates a context. Please note a few ways this stem and leaf diagram is actually drawn. First of all, like I mentioned, the stem is on the left, the leaves are on the right, but also the fact that everything is lined up perfectly. That is very, very, very important. You need to line up your stem and leaf diagram. So notice it's not like 1 with the line and then 8, 9, 9, and then 2 with the line 1, 3, 6, 7, really spread out. You can see that everything has vertically lined up. Nice and neatly, really vertically lined up perfectly. That's what allows us to be able to consider any value in the data shape, we could say, the data shape. So you just need to be really aware of that. So evenly spaced vertically and horizontally. Notice that there are no commas between the leaves. Please don't put any commas in there. It's really very straightforward, very plain, this type of diagram. Notice there's no heading here as well. For a regular stem and leaf diagram, you don't need any headings, you don't need any commas. You just need to be very aware of how this data is drawn. From there, of course, you can then, you can easily see that the smallest number in this stem and leaf is 18. The largest age, I could say, is 60, and you've got everybody else in between. So if I was ruling people off, I would say, okay, that's the 60, then there's a 55-year-old, 53-year-old, 47-year-old, 46, 41, and I actually can count the amount of data just by counting the leaves. If you are a little bit confused, you can write it all out first, and then you can deal with the measures of central tendency, for example, if you were doing mean, median, and mode, and also, of course, range. So that brings me to a back-to-back stem and leaf diagram. These are used when you need to work with two distributions. So have a look at this example here. So time spent reading a book. In this example, you do need a heading, okay? Because you now have two stem and leaf diagrams back to back. That's literally what it's saying. So you've got the stem and leaf diagram. If we just didn't look at the males for a second and we just considered the female side only, that entire side is a regular stem and leaf diagram, and that matches what we had above. The male side is the exact same thing, just almost like in reflection, okay? And one big point that I didn't mention that I hope you've noticed is that all the leaves, so in this example, you've got the stem in the middle and you've got the leaves out here and the leaves out here, all the leaves are in order of size. So they always start at the smallest to the largest. That's how it goes in order of size, of course. Same thing for the males, except the smallest starts in the middle and then works its way outwards to the largest leaf, okay? And that way, once again, you can very quickly see the distribution. So if this asked you to comment on the type of distribution in this particular diagram, you can clearly see that if we're talking about time, and it could be minutes, it could be hours, I haven't even considered the key yet. If we're talking about time, immediately I can see that the males read for less time than the females in this particular distribution. I can already draw that conclusion from the shape of this data. If I have a look at the key, we've got 3 with the line 2 represents 32 minutes. So I know that that's 32, 34, 35, and going back for the males, 30, 31, 32, 33, etc. So the lowest time is 30 for the males, 32 for the females. Highest time is 79 for the females and 77 for the males. I just want to draw your attention very quickly to this key under here. That's just another way of representing the key for a back-to-back stem and leaf, because you've got the 0, the 3 as the stem in the middle, and then the 2. So it's indicating 30 for the males and 32 for the females. That's just another way of doing your key. Either way works fine. And then from there, like I've said, all of that data is, if we listed the female data, it's there. And from there, you can start to work out the mean, median, mode, and range. And for the median, it's really very easy because you can cross things out. So for example, I can say that's the largest, because it's already in order of size with those leaves. So that's the largest, that's the smallest. And I can cross them off, for example, to be able to get to the middle. I can also work out that median the mathematical way and then count to, the 12th bit of data or the 15th bit of data very easily because I count through the leaves, okay? So there's a few different ways to do it. You can calculate the mean by just adding them all up again and again, counting the leaves, because that's how much data there is for the males and the females. Okay, give them a go. Good luck.